Hey, how's it going? It's Keith Townsend from the CTOadvisor.com. You know what? We're still here at AWS reInvent. Val Bercovici,
Perfect.
co-founder. And what's your title these days? Because the company has grown.
Company's grown. We're north of 10 people now. I'm co-founder and CEO.
Okay.
Two other key co-founders, Kumar Palaniappan, he is our CTO. And Scott Sanchez, a little easier to say, he's our CSO, but effectively go-to-market lead, Chief Strategy Officer, and all things go-to-market.
And that makes sense that he's the CSO because as we're talking about the go-to-market strategy and his kind of come-to-market question of why would you buy the solution. You know, this is something that we've talked about over the past couple of years. You know, as the vision of PencilDATA has grown and you guys have talked to potential customers. You've come out with a product. It has matured. You know, from a buzzword perspective, you guys have all of the buzzwords: blockchain, data, multi-cloud. But this is something, you know, you have a data fabric, a data focused history with your experience in enterprise data. You know the pain points that customers have around data. The cloud introduces new pain points. What's the latest vision for PencilDATA?
So the latest vision, and has been for quite some time, is all around adding the strength of blockchain to enhance business integrity. So the use cases, particularly as Scott, brought him forward by asking that important question, when would you buy as opposed to what would you buy? The use cases have been fascinating. One of the better ones I can think of right now is in the medical imaging space. So you've got MRI machines in hospitals now.
Right.
We're doing a pilot in Minneapolis with an array of 12 MRI machines in one hospital. First thing that stands out is they generate 100 million images per year.
That's a lot.
That's a lot. And this is healthcare. So it's regulated. The authenticity of those images is really important. Particularly these MRI machines now are getting advanced. They've got some machine learning built into them, automatically, detect or perhaps even pre-diagnose tumors or things like that. So people really want to know what the original authentic image was, what the interpreted image was, perhaps some other derivative things. And we don't store that data. We don't control that data per se or protect it. We verify the authenticity of that data. So we register it when it's captured. And then when a fellow specialist or the insurance payer or some regulator down the road wants to verify the authenticity of that image, we help verify the authenticity of the image. And it can be shared, it can be leaked even, unfortunately. We can't control that. But for insurance purposes, for regulation purposes, for all sorts of other things, and I'll talk a bit more about these use cases, it's deeper than that. For supply chain integrity purposes, we verify the authenticity of these things.
So, it's one of those use cases that once you hear, you think of, obviously. I have a relative that I just talked to earlier today that they had to go get a image. They live some distance away from their hospital. They went and got some scans done. That relative needed to give those scans to a different provider, healthcare provider. So they literally had to go make the trip back to go pick up the scans physically to take it to another healthcare provider. And I'm thinking, wow, that's a really easy email to send or something to that case. But to your point, it's healthcare data and it's not that simple. And as we think about some of the physical examples of how we want to use blockchain, it's all about the integrity of the supply chain. If the egg, you want to find out how the chicken had salmonella, well, what if we could track it all the way, the supply chain, all the way back to the egg?
Exactly.
Same concept.
Yeah.
So let's talk about a little bit about the technology. I got the applicability, the technology itself. Like when I think of data, I think of something that can how that abstraction of like an image and the token or blockchain token associated with that image, how that abstraction can easily be broken.
Right.
How do you guys ensure that the piece of data that was generated and the token that's associated to that piece of data How do you ensure the integrity of that throughout the entire life cycle?
Great question. And there are a lot of buzzwords in this space. There's a lot of confusion in this space. And ordinarily in a young market, you expect to have a phase of it in the early days be educational.
Right.
So I remember Cloudera in the first couple of years wasn't so much a Hadoop distro company. They were a Hadoop training company
I
first.
remember that, yeah.
A lot of revenue and training, and then the distro, started to become more mainstream, and that was a good revenue stream for them. We're finding there's a lot of education needs to be done, particularly not just around blockchain, but around separating the cryptocurrency hype and price and speculation from the very applicable today enterprise use cases and value.
Right.
So there's work we're doing in that space. And specifically to answer your question, what do we do to make it safe? What do we do to make it simple? What do we do on our end to make it scalable? Is take an enterprise approach to it. So you would think that a typical enterprise today doesn't say I'm an Oracle shop if you're of any decent size. You've got SQL Server in there, you've got maybe DB2. If you've got mainframe, you've got Mongo, you've got a whole bunch of NoSQL things like Cassandra and so forth. So there's no such thing as a monolithic database enterprise anymore.
Right.
The blockchain world would like you to believe that, right? The blockchain world would like you to believe that you only need one kind of blockchain, whether it's the Bitcoin network, whether it's Ethereum, whether it's Stellar Lumens, the Waves platform, what have you.
Mm-hmm.
You and I know in the enterprise things don't work that way.
No.
So one of the first decisions we made is to build a lot of investor protection in, so customer investment protection in, by abstracting from any one specific blockchain, by offering the integrity value across multiple blockchains, in some odd cases in parallel, maybe more than one blockchain, in reality one at a time, but not being stuck to one. So if you start, as many customers want to, let's say on a private blockchain, and more comfortable that way, we support the common flavors of Hyperledger today, so that historically was Fabric that was contributed by IBM, Sawtooth by Intel.
Mm-hmm.
We're looking very much forward now to working with the Intel, so not the Intel Sawtooth, but the VMware Project Concord team, and helping not only introduce that to the market through the Hyperledger Foundation, but more importantly, what we directly add value to is accelerating enterprise adoption of. So accelerating enterprise adoption of Project Concord is something we're looking forward to, and that'll be the third Hyperledger blockchain that we support. And we always knew we'd need at least one public blockchain, and there's several now, but the first one we support is Ethereum.
So I've never heard anyone say that they're going to abstract away the underlying blockchain and provide value on top of that so that you can bring the blockchain that meets your business requirements. So if you're looking at a Hyperledger and you want a Hyperledger that provides not only the validation of the transaction, but offers some level of I don't want to call it community and reputation.
Yeah.
So IBM is built big on how do you validate. Yes, this person validated the blockchain, but just because they validated that transaction doesn't mean that I should trust them.
Exactly.
How do I trust that person? So while in Bitcoin that may not be necessarily an issue in Bitcoin, when you're doing business-to-business transactions, reputation matters.
Absolutely.
And if the blockchain can provide that, great. Now, as I look at applications that sit on top of the blockchain and consume it, how do I make sure that my application enables me to use all of the value of that inherent blockchain?
Absolutely.
So from a product perspective, have you gotten to the point that this is a product that you guys can offer and sell?
So we released a public beta around April of this year, and it was just a really pleasant surprise in terms of the breadth of use cases that came forward. So we just scratched the surface on a medical imaging one. There's actually a lot more to that one. There's autonomous vehicles, autonomous taxis is one of our use cases, and ironically, it's a very similar workflow to the medical imaging one in terms of you've got a complex device, an industrial IoT machine, as I like to call it, with many, many versions of software that have to be certified. And
right.
We enable that through the blockchain. Lots of sensor state configurations. So I have to refer to the unfortunate fatality in Tempe with the Uber and Volvo SUV. You have to remember there, the software worked 100% perfectly. The sensors functioned 100% correctly. What led to the fatality was plastic bags floating across the street, slowing the SUV down. And the Uber engineers or the operators decided to, gradually detune the sensitivity, the motion detectors, the motion sensors, so that at least initially the SUV did the right thing and drive through a plastic bag and not make the ride unpleasant, not slow down, not use more energy or so forth. But unfortunately, they didn't know where to stop. And they kept detuning to the point of, unfortunately, not being able to sense in the dark an actual pedestrian, and we know what happened afterwards. So insurance companies are now wise to this. And it's not just about ensuring the car is a simple, opaque atomic thing. It's about digging deeper. What were the software releases, of all the of all the firmware and all the other software supply chain components that led to the master image of the car? What were the neural network algorithms trained as to identify objects and take corrective action? How were the sensors configured? All those questions need to be answered. So it becomes a very granular use case now where, let's say, for every new passenger in a self-driving taxi case, you've got to certify the complete state of the vehicle, hundreds of sensors, hundreds of individual software releases, as well as the GPS coordinates, as well as the infotainment data, as well as camera frames, particularly if an incident like an airbag sensor deploys during a ride, something happened. So it's really important to know what the camera frames were before and after, and it's really important for the first responders to trust that data, for the insurance claims adjuster the next day to trust that data, and for the NTSB regulator, for years on out, to trust the authenticity of that data as they're making policy.
So a lot of questions popped up into my head as you're describing it. One is not even the question, it's more of use cases. My daughter does, she works for a healthcare insurance provider, and she does call tree algorithms. And I was talking to her about, obviously one of the things, when a geek sees a flow chart, we can't help but to ask questions. And the one thing that I, asked her about was like kind of revision controls, because as she was describing it to me, I'm like, oh, that's just a development pipeline.
Yeah.
And you guys have all the challenges of a CI/CD pipeline. So I'm asking her these, what she thought was brilliant, intuitive questions, or just, questions we get in enterprise IT all the time. So that's just, an obscure, just another example of a use case that can use that, because when you have multiple sources of data inputs and where people can either manipulate that data or add to the overall data repository or data lake, I'm throwing another buzzword in there. It's critical that as you're building technologies or infrastructure on that data, the data has now in fact become infrastructure, and it just has to be reliable. Absolutely. And when it's not reliable, you have to be able to trace back to where the data was manipulated or corrupted, so that caused a problem. Or even if the data didn't corrupt, what changed, or what did we not consider? Or where was the point of change? So one of the inherent advantages and I guess disadvantages to your approach is, one of the disadvantages is that you're reliant upon the underlying blockchain. So as we look at the underlying blockchain today, the technology, you mentioned the different projects. One of them is Concord. The challenge with the technology right now is that the transactional speed isn't there for the scale that most enterprises will need at scale. There are niche examples. Your healthcare example is a great one, where the speed of transactions, the latency really doesn't matter in that solution. The images don't move that fast between hospital to hospital yet. But as the overall solution scales, or lack of scale, where are you finding kind of, I guess you haven't ran into a practical problem yet with the limitation of the underlying blockchain, but what do you see where improvements have to be made so that ultimately PencilDATA is successful?
Great techie question. So enterprise people always have solutions to this, right? I mean, engineering scale is one of the most fun propeller head things to do. We have the benefit of having a less is more approach. So one of the things we educate our customers on early on is that, we don't do crypto. So there is an underlying token, and there's currently a market value, like every minute, every second, to that token. We don't depend on that value at all.
Right.
We don't even depend on the token itself. We depend on the integrity of the blockchain that the token itself depends on.
Exactly.
That's the key thing for us. So we're able to implement, much like Bitcoin, if you've read about Lightning, Ethereum with Plasma, and other solutions, these are now a whole category of off-chain scaling solutions that address specific use cases that literally are designed to complement the blockchain, because a really good blockchain is highly decentralized, but in that, particularly globally distributed, there's network latency inherent, there's just size of blockchain, there's all sorts of latencies, in terms of actually transacting on a blockchain. So an off-chain solution is designed to specifically address certain use cases and be true and be loyal to the underlying blockchain itself.
So now that you rely on the actual token, you've abstracted, this is the advantage of abstracting from the blockchain, from the independent blockchain, from individual blockchains, that you've abstracted the challenge of latency and settling transactions, whereas you can use off-blockchain solutions to do the settling of transactions. You're relying on the blockchain for the integrity, but not for the actual transaction.
Yeah, and we all remember, 10 years ago, we were all learning about eventual consistency for
Right.
SQL databases. We've got something, we're not patenting the term, but we have a patent that uses that technology called eventual consensus. So because we don't do cryptocurrencies and we don't depend on token values and things like that, we have a much simpler surface in terms of attacks
Right.
defend against, replay attacks, Sybil attacks, and so forth. So we're able, loosely, without disclosing too much in our patent because it's still pending, we buffer a lot of decentralized registrations on our platform and verifications. It's the power of registering something in multiple locations automatically and then having it verified by multiple locations automatically is really what the integrity is based on. But we're able to do that by buffering it to a very conventional NoSQL database up front. We assume full chain of custody as soon as we do that. So we use hashing technology internally to make sure that our database transactions haven't been tampered with.
Right.
We detect that as well. And we put all that on the underlying blockchain. But by essentially buffering it with a database up front, we can give you near instant latency, even to the point of not just millisecond latency, but microsecond, if you need that. Not any customers are paying for that yet,
Right.
but we've designed it to support that kind of latency. And also a near zero cost, a very fractional cost, a fraction of a token value, a fraction of fiat currency like a US cent. And so that it becomes very, very efficient. That's the default configuration for most of our customers. And we always allow customers to basically use our very simple interface. That's part of our real visible value to customers, is instead of learning about wallets and smart chain or smart contract programming and token economics and governance of blockchains, we offer two RESTful APIs: register, verify. Super simple. That's really where we get a lot of our enterprise traction from. But if you can do that, by default, you don't pay a lot of cost or anything, and you don't have a lot of latency. If you want the power of the raw blockchain, we expose that to you.
Wow. So, I have a ton of questions. Like we could talk about this probably for the next hour and a half and not scratch the surface. You guys have been doing a lot of work over the past couple of years bringing this to market. I'm super excited to see the product mature in a while, because I think you solve a legit concern as data becomes more diverse. We're diversified. We're at AWS reInvent. People are talking about multi-cloud, the ability to transact business across the world, across the same data set. This challenge will be perverse. So looking forward to seeing the work that you do. Until the next time we get to sit down, if people were anxious to talk to you and engage PencilDATA, how do they do it?
So you can find out more about the company itself at PencilDATA.com. The service, that's effectively a simple blockchain platform, is so popular we branded it as ChainKit.com. It's got a Twitter handle. PencilDATA has actually an underscore. That's a long story about how Twitter does governance of Twitter accounts, but it's Pencil_Data. And of course myself, Val Boo on Twitter, and we've got Scott Sanchez on Twitter, Kumar is Mega MDA, I think, on Twitter. Lots of ways to find us. We're on LinkedIn, of course, as well.
I appreciate you stopping by the CTO Advisor. I guess we can label this the CTO Advisor Suite at AWS reInvent. Enjoyed having the conversation. If you want to find more conversations like this, you can find me on the web. TheCTOadvisor.com is the website where we post all of these videos. You can find me on Twitter at CTO Advisor, and of course on LinkedIn you can do a Google search or LinkedIn search for Keith Townsend. Until then, we'll talk to you next CTO Dose.